Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good evening. Here, I will brief about the IDP project. The title is Smart Oximeter with Emergency Button for Bedridden Patient. So, we are from group HG17 and the supervisor is IR Dr. Farhana Hani binti Mahmud. Next, for this group, we have 3 group members. Firstly, me, Ajmal Danish bin Muhammad Zamri, the metrics number is CE210 and 217. Second, have Muhammad Nizam bin Zahari, the metrics number is CE210005. And the third person is Muhammad Anis Mustaqim bin Muhammad Shuhaimi, the metrics number is CE210188. Next. The introduction for this project is, in recent years, the lack of nurses has become a major issue for the healthcare industry based on the Healthy Ministry MOH project a shortage of roughly 8,000 nurses for 2023 and 2024. This represents a substantial gap considering the current nursing workforce of around 115,000. Due to a lack of nursing professional, the number of patients frequently outweighs the capacity of healthcare facility to provide one-on-one care. As a result, there are very few hardware instruments available for patient treatment.
Next, for the problem statement, nurse or guardian has difficult time to monitor bedridden patient when there are other daily routine to do. Then, bedridden patient has limitation where they needs to stay in bed. Therefore, they have difficult to call nurse when they have any problem or emergency. Lastly, nurse or guardian needs to check up on each patient in order to check their pulse and oxygen level. Then, for the objective, firstly, to design a system that monitor the patient pulse and oxygen level through smartphone. Second, to build a system that will notify the nurse or guardian when the patient press the emergency button through the smartphone. Third, to test the system integration for performance evaluation. Then, I will pass to Muhammad Anis Mustaqim to present the project demonstration.
Next, I will demonstrate the project. First, turn on the switch and make sure the Wi-Fi or hotspot is active. Once the ESP connected to the Wi-Fi, it will power up both the LCD and oximeter sensor. Here, the 3D printed finger tip holder designed to secure the sensor and finger tip together. This is the push button for the emergency notification. Second step, place your finger in the holder, ensuring it touches the sensor. The ESP will then start taking the BPM and SPO readings. The result will be displayed on both the smartphone and LCD. Looking at the LCD, we can see the current reading is 83 BPM and 96 SPO. Moving to the smartphone, we'll observe live reading updating every 1 second. The phone will send notification if the SPO drop below 80 or if the BPM fall outside the normal range, which is 60 to 80. Finally, pressing the emergency button will trigger a pop-up emergency alert on the phone. That's all for the project demonstration. Lastly, let's compare our smart oximeter sensor with a medical device. I have my right fingertip connected to our sensor and my left fingertip connected to the medical equipment. As you can see, the results displayed by the both devices are nearly identical. This demonstrates that the accuracy and usability of our project for monitoring blood pressure and oxygen are usable.
Lastly, for the conclusion and recommendation, the smart oximeter with emergency button for bedridden patient is a promising solution for bedridden patient, providing real-time vital sign monitoring and a quick response emergency button. The project success depends on the ability to stay under budget completely with regulation and adapt to changing healthcare technology landscape. Data security and patient privacy should be prioritized, and long-term viability depend on tracking market demand and innovation. The project has the potential to improve bedridden patient quality of life by providing prompt medical attention and monitoring.